So before we do the partial fractions decomposition, we have to check the order of the partial fractions here. So the numerator, the order is 0 because the highest power of x is 0, there is no x, and here the highest power of x is 2. So this is a proper algebraic fraction, so we can go ahead with the partial fractions decomposition. So for the partial fractions part, we need to identify the forms we have to use because of this simple distinct linear. Use a constant divided by that, and same thing here, a constant divided by that, and then we multiply both sides with the denominator. We cancel out. On the left we have only the numerator, and on the right, when we multiply the first term, we cancel out. We have a times 2x plus 1, and from the second term, multiply, cancel out, b times 2x minus 1, and we plug in the zeros of the divisors here. So we plug in 1 over 2. So if we plug in 1 over 2, there's nothing to plug in on the left. On the right, we plug in 1 over 2, we get 2, and here if we plug in 1 over 2, we're gonna get 0. So we say that this term goes to 0 because 1/2 is the 0 of 2x minus 1. So actually that's how we find 1/2. That's by solving 2x minus 1 equals 0, we get 1/2, right? So again, we can find the a here, and to find the b, we plug in minus 1/2 because this term will go to 0, and from here we're gonna get minus 2. So the b is therefore minus 1. So the final answer is, this is a, this is b. So this is the same as 2 over 2x minus 1 times 2x plus 1. Okay, so that's the final answer for the first part. For the second part, so we are squaring f of x, which was this before from the partial fractions. This is the f of x. So when we square this, we use the a plus b all squared formula. So if you don't remember that, just multiply this by itself, and with step by step, this times this, we get this squared, and this times this, we get this times this, we get this, and this times this, we get this. Okay, so this is the same as 1 over 2x minus 1 all squared, and this is minus 1 times minus 1 is plus 1, so this is what we get. So it's plus and this is exactly the same, so just add the numerators, minus 1, we get minus 2 here. And if you look at this again, this is exactly the same as the original f of x. So actually that is the same as the original f of x. So this is the original f of x, so we can replace it with the partial fractions, this from the answer to part 1, and without the brackets, minus times minus 1, minus times minus 1, this is what we need to prove. All right.